For our Precalculus 101, we're going to discuss Module 3 about parabola. For the objectives, at the end of the lesson, you will be able to define a parabola, determine the standard form of the equation of a parabola, and graph a parabola on a rectangular coordinate system. To start, let us have these definitions. Parabola is a curve formed from all the points x, y that are equidistant from the fixed line called the directrix and a fixed point called the focus. In our figure, the blue curve is our parabola, the green line is our directrix, and the red point is our focus. The line perpendicular to the directrix and passing through the focus is called the axis of symmetry. In our figure, the vertical purple line is our axis of symmetry, and it divides our parabola into two symmetric parts. The line chord that passes through the focus and perpendicular to the axis of symmetry is called the latus rectum. In our figure, the orange line is our latus rectum, and its distance is 4 times the distance from the vertex to the focus. The point on the parabola midway between the latus rectum and the directrix is the vertex of the parabola. It is the point where the curve changes direction. In our figure, the yellow point is our vertex. It is either the highest or the lowest point in our parabola. Now, let us have the equation of a parabola in standard form. For the first set of standard form of the equation of a parabola, we have x minus h squared equals 4p times y minus k. The opening of the parabola depends on the value of p in the equation. If p is greater than 0 or positive, then it opens upward. On the other hand, if p is less than 0 or negative, then it opens downward. The vertex of the parabola is denoted by the point hk, and the focus of the parabola is denoted by the point hk plus p. The axis of symmetry is denoted by the equation x equals h, and the direction is vertical. The directrix is denoted by the equation y equals k minus p, and the direction is always horizontal. Remember that in this first set of the equation of a parabola, the quantity that is squared is the term which has the x term. Now, let us have our first example. Our equation is x squared plus 4x minus 8y plus 28 equals 0. For the first step, we're going to write this equation in standard form. Using the equation x squared plus 4x minus 8y plus 28 equals 0, we're going to isolate the terms having x variable, y variable, and constant. In our example, we're going to write x squared plus 4x, or the terms having x variable on the left side, and then we are going to write negative 8y and plus 28 to the right side of the equation. Therefore, we have x squared plus 4x equals 8y minus 28. Next, we're going to make the left side of the equation a perfect square trinomial by completing the square. To do that, using the coefficient of x, which is 4, we're going to divide it by 2 and then square the answer. So 4 divided by 2 is 2, and the square of 2 is 4. Then we're going to add that number to the left side and right side of the equation. Therefore, we have x squared plus 4x plus 4 equals 8y minus 28 plus 4. Next, we're going to simplify this part of the equation by adding negative 28 plus 4. Thus, we have x squared plus 4x plus 4 equals 8y minus 24. And for the final step, we're going to factor x squared plus 4x plus 4 and 8y minus 24. For x squared plus 4x plus 4, we're just going to get the factors by first getting the square root of x squared, which is x, then get the sign of the middle term, which is plus, and get the square root of the last term, which is 2. Then enclose that in a pair of parentheses and square the whole terms. Therefore, the factors of x squared plus 4x plus 4 is x squared, or x plus 2 squared. How about the factors of 8y minus 24? Simply get the greatest common factor of 8y and 24, and that is 8. Then, to get the other factors, simply divide 8y divided by 8, that is y, and negative 24 divided by 8 is negative 3. Therefore, our final answer, or the standard form of the equation of the parabola, is the square of x plus 2 equals 8 times y minus 3. For step number 2, we're going to identify the characteristics of the parabola using the standard form of the equation. Using our answer in step 1, which is the square of x plus 2 equals 8 times y minus 3, let us have first the opening. Using the term outside y minus 3, which is positive 8, we're going to get the sign of this term. If it is positive, then it opens upward. If it is negative, therefore it opens downward. And since it is positive, therefore our parabola opens upward. For the vertex, we're going to identify the values of h and k. But remember to change the sign of the numbers in our standard form of the equation. Therefore, our vertex is at negative 2, positive 3. In our Cartesian coordinate plane, you can plot our vertex at this point. Next is our focus. To find the focus, we're going to use again this number, which is 8, and equate it to 4p. And then we're going to solve for the value of p by dividing both sides by 4. Therefore, p equals 8 divided by 4, which is 2. Using p equals 2, that means from the vertex, we move 2 units upward, and that is the orange point in our Cartesian coordinate plane, and that point is -2, 5. Or simply add the value of k, which is 3, plus the value of p, which is 2. Therefore, your ordinate will become 5. Next, using again 8, that means you have 8 units for your latus rectum. So from the vertex, or from the focus, you move 4 units to the left and 4 units to the right. That is total of 8 units. Then now, you can graph your parabola. How about the axis of symmetry? So the axis of symmetry is the line which passes through your vertex and your focus. In this case, it is a vertical line, and remember, for vertical line, it is always in terms of x. So we simply identify the value of x in the x-axis where the line passes through. In this case, it passes through x equals -2. Or simply identify the abscissa of your vertex. How about the directrix? Remember that the directrix is always the same units from vertex to focus. Since from vertex to focus we have 2 units, then we also move 2 units downward from the vertex, and that is this line. Since it is a horizontal line, therefore it is always in terms of y. So identify where the line passes through our y-axis, and that is +1. Therefore, our directrix is y equals 1. For example number 2, let us have x squared minus 8x plus 12y plus 4 equals 0. So let us write this equation in standard form. Using the same steps, x squared minus 8x plus 12y plus 4 equals 0, we're going to isolate the terms having x on the left side, while the terms having y variable and constant on the right side. Therefore, we have x squared minus 8x equals -12y minus 4. Now, let us make the left side of the equation a perfect square trinomial using this coefficient of x, which is 8. Again, divide it by 2 and square the answer. That is 8 divided by 2, 4, and the square of 4 is 16. Therefore, we add 16 to both sides of the equation. Therefore, we have x squared minus 8x plus 16 equals -12y minus 4 plus 16. Then we simplify the right side of the equation. -4 plus 16 is +12. For the last step, we get the factors of this x squared minus 8x plus 16 and -12y plus 12. That is the square of x minus 4 equals -12 times y minus 1. How did we get these factors? The square root of x squared is x. Get the sign of the middle term, which is minus sign, and the square root of 16 is 4. Then square those values. On the right side of the equation, greatest common factor of -12y and +12 is -12. Divide -12y divided by -12 is +y. 12 divided by -12 is -1. Therefore, our standard form of the equation of the parabola is x minus 4 squared equals -12 times y minus 1. For step 2, we're going to again identify the characteristics of the parabola using the standard form of the equation. Using our answer in step 1, let us have the opening. Since this number is negative, therefore, our parabola opens downward. For the vertex, or the values of h and k, therefore we have 4, 1. In our Cartesian coordinate plane, this is our vertex. For the focus, we use this number and equate to 4p. 4p equals negative 12. Divide both sides by 4. Therefore, p is equal to negative 3. That means from the vertex, we move 3 units downward. And that point is at point 4, negative 2. Or simply, subtract the value of k, which is 1, and 3. Therefore, our abscissa is 4 and our ordinate is negative 2. Since we have negative 12 as our value outside y minus 1, that means we have 12 units for the latus rectum. That means from your focus, you move 6 units to the left and 6 units to the right. Then you can now graph your parabola. How about the axis of symmetry? So you draw a line passing through your vertex and focus. In this case, it is a vertical line. That means would be in terms of x, and it passes through x equals 4. And our directrix would be 3 units upward from the vertex, which is this line. Since this is a horizontal line, therefore our equation is y equals 4. Now, let us have the next set of the equation of a parabola. In this case, our standard form is y minus k squared equals 4p times x minus h. Remember that in this set of standard form of the equation, the term or the variable having the square is our y. So there are two possibilities if we have the square of y in an equation. It is either opening to the right or opening to the left. It depends on the value of p. If p is greater than 0, therefore, it opens to the right. If p is less than 0, then it opens to the left. Vertex is still hk. Focus is at h plus p, k. And our equation for axis of symmetry is y equals k. Direction is always horizontal. Directrix is given by the equation x equals h minus p, and the direction is always vertical. Now let us have example number 3. The given equation is y squared plus 6y minus 4x minus 7 equals 0. Step 1. Let us write this equation in standard form. Y squared plus 6y minus 4x minus 7 equals 0. In this case, we're going to write the terms having y variable on the left side, and then we write the term having x variable and constant on the right side. Therefore, we have y squared plus 6y equals 4x plus 7. By completing the square, we divide 6 divided by 2, that is 3. Then square the answer. 3 squared is equal to 9. Therefore, we add 9 to both sides of the equation. So we have y squared plus 6y plus 9 equals 4x plus 7 plus 9. Adding 7 plus 9, we have 16. And factoring y squared plus 6y plus 9 and 4x plus 16, we have y plus 3 squared equals 4 times x plus 4. And that is the standard form of the equation of our parabola. Step 2. Now let us identify the characteristics of our parabola using the standard form of the equation that we got on step 1. Using y plus 3 squared equals 4 times x plus 4, let us identify its opening. Using 4, and 4 is positive, therefore, our parabola opens to the right. For the vertex, that is our h, and this is our k. Remember that h comes after x and k always comes after y. Therefore, our vertex is at -4, -3. And in our Cartesian coordinate plane, that is our vertex. For the focus, using this number, we equate it by 4p. So we have 4p equals 4, and dividing both sides by 4, we have p equals 1. That means, to locate the focus, we move 1 unit away from the vertex going to the right. So that is our point, and on our Cartesian coordinate plane, our focus is at -3, -3. Now, using 4, or the length of our latus rectum, therefore we move 2 units upward and 2 units downward from our focus. Now, we can have our parabola. For our axis of symmetry, we draw a line passing through our vertex and focus. And since it is a horizontal line, therefore our line is in terms of y, and it passes through -3. Therefore, our equation for our axis of symmetry is y equals -3. On the other hand, our directrix should be 1 unit away from our vertex going to the left. And that equation of our directrix is in terms of x because it is a vertical line and it passes through -5. Therefore, our equation is x equals -5. Now, let us have our last example. We have y squared minus 8y plus 8x minus 24 equals 0. Let us write this equation in standard form using the same process. Y squared minus 8y plus 8x minus 24 equals 0. We write the terms having y variable on the left side and the terms having x variable and constant on the right side. So we have y squared minus 8y equals -8x plus 24. Now let us complete the square using this number. So we have 8 divided by 2 is 4, and 4 squared is 16. Therefore, we add 16 to both sides of the equation. Next, we simplify 24 plus 16, and 24 plus 16 is 40. Now, let us get the factors of y squared minus 8y plus 16 and negative 8x plus 40. Factors of y squared minus 8y plus 16 is the square of y minus 4, while the factors of negative 8x plus 40 is negative 8 times x minus 5. So that is our standard form of the equation of the parabola. Using this equation, let us now identify the characteristics of the parabola. Using negative 8, and it is obviously negative, therefore our parabola opens to the left. For the vertex, we identify h and k, therefore our vertex is at 5, 4. In our figure, that is our vertex. For the focus, we equate this number to 4p, so we have 4p equals negative 8, dividing both sides by 4, therefore p equals negative 2. That means, to locate the focus, we move 2 units away from the vertex going to the left. That is that point. And that point is located at 3, 4. Therefore, our focus is at 3, 4. Since our value outside x minus negative 5 is negative 8, that means we have 8 units for our latus rectum. So from the focus, we move 2 units upward, 4 units upward and 4 units downward for our latus rectum, and now we can draw our parabola. For our axis of symmetry, we draw a line passing through our vertex and focus, and since it is a horizontal line, therefore it is in terms of in terms of y, and it passes through 4 on the y-axis, therefore our equation is y equals 4. And our directrix is 2 units away from the vertex going to the right, and it is in terms of x since it is a vertical line passing through 7, therefore our equation is x equals 7.